Hi folks, today we'll learn about projectile motion. As you can see in the diagram, we have a projectile which is thrown with an initial velocity of u at an angle of theta with the horizontal. We have to find out the range of the projectile and the maximum height reached, and as well as the equation of trajectory. Let us divide this motion into two parts: the motion along the x direction and the motion along the y direction. So we'll tabulate the results. The velocity along the x direction can be found out as ux, which is equal to u cos theta, the component of the initial velocity u along the x direction, and the velocity along the y direction would be uy, which is equal to u sin theta, this one, which is the component of u along the y direction. Acceleration along the x direction is 0. Acceleration along the y direction is negative g. We have taken all the distances or all the velocities, all the parameters in the upward direction as positive, rightward as positive, left as negative, and downward as negative. The total displacement Sx is the range if we consider the initial and the final position, which is equal to r, which is also equal to u cos theta t if we take t as the total time of flight. Now going to the y analysis, Sy would be equal to 0 because this projectile starts from origin and it ends up on the x-axis, and we know the equation of x-axis is y equals to 0. So here at Sy equals to 0, the projectile will travel a distance which is equal to u sin theta t plus half minus of gt square. Now you can find out the time of flight by solving this equation Sy equals to 0, which is equal to u sin theta t minus half gt square. We'll get two values of t from this quadratic equation. One is 0 and the other one is 2u sin theta by g. Now the 0 signifies the beginning of the flight, which is the origin, and time 2u sin theta by g signifies the end of flight. Now you can put this data t equals to 2u sin theta by g in this Sx equation to find out r, and r is u square sin 2 theta by g, which can be reduced from this form 2 sin theta cos theta to sin 2 theta. Use some trigonometry here, and h can be found out by just replacing the value of half of t, because we know that this total journey is symmetrical, and at t by 2 the projectile would be at the maximum height. So you'll get the value of h as u square sin square theta by 2g. Now the equation of trajectory, it's quite simple. Let us take any position y. So Sy would be equal to y, and corresponding x position would be x. So just put the value of t as x by u cos theta in the equation, y equals to u sin theta, replace that t, and you will come to this equation. Hope you have learned a new thing today, and I'll be coming back with a lot of more numericals. This is Anirban Saha signing off from estudies.com. Visit my blog cbsephysics.pune.wordpress.com for more numericals. Thank you.